All right. We're going to talk about two other systems that you're going to go, why the hell are we even talking about them? Because they're important to understand for surfaces. Because in molecules, these two other interactions have no impact on the MOs, on the bonding. Well, then when you throw in a surface or a solid, things change. So it may seem silly and stupid right now. There's a reason for it later on. Am I cool to erase this thing? Okay. I'm just going to erase the center because we're going to draw another MO diagram in a minute. The next thing I want to talk about is Pauli repulsion. Did I? Yeah, I did. Just Paul. Paul repulsion. Good old Paul. I love Wolfgang Pauli, though. He had the meanest, meanest things to say about people. It's pretty entertaining. He's just mean. What is it? Like one of his favorite quote, this is not it. This is so bad that it's not even wrong. Like that's like.
That's like an analytical lab.
Yeah, Dr. R being snarky. I guess Pauli was snarky.
Yeah. He goes, I just put none of the above on my exams. That way if I mess the question up, I'm still not wrong. Awesome.
That's a smart tactic.
Yeah, he's really good at doing that.
All right, we're going to consider two molecules again, A and B, and they interact via filled MOs. So let's pretend it's the HOMO of two systems interacting. It has the correct symmetry, correct energy to result in good overlap. So we have a system like this, 2 electrons in here, 2 electrons in here. We're going to get an anti-bonding combination and a bonding combination. We've got to fill our electrons. There we go. So my first question is, what happens to the bond order? Yep. Zero, it doesn't change. However, what happens to the net energy of the system?
Are those supposed to be equally spaced or no? No.
The anti-bonding should be higher in energy by a bit. Mm-hmm. Yep. The net energy of the system. Yep, it increases. Because let's look at this distance. Let's call this delta E1. And this distance is delta E2. What always has to be true about the relationship between delta E1, at least for this system? Which one's smaller? Yep. Always less. So if these guys keep overlapping, this energy gets way more destabilized, right? And it's unfavorable. What's that? Generally, it wouldn't. What would these two molecules do to one another? Yeah, they would repel. They don't want to do this. They would repel. The other thing is you're localizing a lot of charge in one specific area. You're leading to no net bonding. It's just not happy. Yep, helium-2, not favorable.
Oh yeah, we did that for every problem.
Yep, back in Gen Chem. So my next question, what is the net effect? Is it effect or effect? Okay. What's the net effect? What are the molecules going to do? Yep. They'll push each other away. Okay. With surfaces and solids, this doesn't necessarily have to happen. There's a way to remove these electrons in those types of systems. If I were to pull out these electrons, what would happen to the bond order? It would increase. There's going to be some cool stuff we're going to see with solids.